वेलकम व्यूअर्स। इस सीरीज में हम ऑर्गेनिक केमिस्ट्री के बेसिक कॉन्सेप्ट्स को समझने की कोशिश करेंगे। बिल्कुल शुरू से शुरू करेंगे इसको और धीरे धीरे बढ़ते हुए एडवांस रिएक्शन मैकेनिज्म तक हम पहुंचेंगे। इसमें एक एक स्टेप समझते हैं आप और वो चीज़ें आपको समझ में आ जाएंगी। तो सबसे पहले हम लेते हैं एटम। ये किसी भी एलिमेंट का स्मॉलेस्ट पार्ट जो होता है वो एटम है। कोई भी एलिमेंट अपने एटम के द्वारा पहचाना जाता है। हर का एटम उसका कैरेक्टरिस्टिक प्रॉपर्टीज रखता है। तो वो एटम किस प्रकार का होता है इसको आप समझें। कोई भी एटम हो, किसी भी एलिमेंट का हो, उसमें एक न्यूक्लियस होता है जिसमें न्यूट्रॉन्स और प्रोटॉन्स रहते हैं। इसके चारों ओर इलेक्ट्रॉन्स रिवॉल्व करते हैं। नंबर ऑफ इलेक्ट्रॉन्स किसी एटम में उतने होंगे जितना एटॉमिक नंबर होगा उसका। जितने इलेक्ट्रॉन्स होंगे उतने ही प्रोटॉन्स होंगे। न्यूट्रॉन्स एटॉमिक मास में से अगर प्रोटॉन का नंबर निकाल दिया जाए तो नंबर ऑफ न्यूट्रॉन्स पता लग जाते हैं। ज़रूरत पड़ने पे उस चीज़ को देखेंगे फिर। तो नंबर ऑफ इलेक्ट्रॉन्स ऐसा नहीं कि चारों तरफ यूँ ही चल रहे हैं, बल्कि डिस्क्रीट एनर्जी लेवल्स हैं। एक एनर्जी लेवल, उसके बाद दूसरी एनर्जी लेवल, फिर तीसरी एनर्जी लेवल। जो जो हम दूर जाते जाएंगे एनर्जी इन लेवल्स की बढ़ती जाएगी। इन लेवल्स को हम एन से रिप्रेजेंट करते हैं। पहली एनर्जी लेवल n=1, सेकेंड एनर्जी लेवल 2, 3, 4 एट्सेट्रा। इसको हम के शेल के नाम से भी जानते हैं। L-M-N। मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स जो किसी एनर्जी लेवल या शेल में होंगे वो 2n² से डिनोट होंगे। इसका मतलब अगर n=1 है तो 2 × 1² that is 2. So this will have maximum 2 electrons. This is the maximum capacity. Similarly, for n=2, 2 × 2² that is 8 electrons in L shell or second energy level. Similarly, 2 × 3², 18 electrons in M shell, and 2 × 4² that is 32 electrons in this shell. Now, exact location of these electrons. Orbital is the region where an electron can be found. Most probably वो उसका रीजन होता है। तो ये जो इलेक्ट्रॉन्स हैं वो ऑर्बिटल्स में बटे होते हैं, ऑर्बिटल्स में रहते हैं अलग। तो किसी भी ऑर्बिटल में मैक्सिमम इलेक्ट्रॉन्स 2 हो सकते हैं और वो दोनों इलेक्ट्रॉन्स भी आपस में अपोजिट स्पिन्स के होने चाहिए। दिस एरोज, हाफ एरोज रिप्रेजेंट द स्पिन, one clockwise, another anti-clockwise. This means there must be one orbital in K shell. In L shell there must be 4 orbitals. In M shell there must be 9 and 16. These orbitals have individual names. The orbital present in K shell is named as 1s. 1 denotes the energy level, number of energy level, and s the orbital. Here there are 4, they are 2s, 2px, 2py and 2pz. Each have at the most 2 electrons. They may be vacant also. Here they are named as 3s, 3px, 3py, 3pz, 3d1, 3d2 and so on, 3d3, 3d4, 3d5, total 9. In 4th energy level, the names are 4s, 4px, 4py, 4pz, 4d1, 4d2, 4d3, 4d4, 4d5 and 4f1, 4f2, 4f3, 4f4, 4f5, 4f6, 4f7. We will now see how the electron filling takes place in these orbitals. We will take first 10 elements here. We are mainly concerned in organic chemistry with these elements. We will head it electronic configuration atomic number, element, 1s orbital, second energy level has 2s, 2px, 2py and 2pz. Then comes the third energy level, which is not required in first 10 elements. गड़बड़ हो गया, एलिमेंट में लिखना चाहिए था इसको. काम कर देना, ये चार्ट बना. We will now see how the electron placing takes place in first 10 elements of the periodic table. Here the atomic numbers 1 to 10, name of elements, hydrogen to neon. These are the energy levels. This is first energy level in which there is only one orbital and this is 1s. Then comes second energy level, which is divided into 4 orbitals. Then comes third energy level, which will not be required up to 10, which will be seen when we discuss sodium onwards. Now the first electron, that is one in hydrogen atom, will come into the orbital of lowest energy, that is first energy level, and in that 1s orbital. When in helium a second electron comes, it will occupy 1s orbital because it is vacant. It can accommodate 2. It will not go in 2, 3, 4. It will come in 2. in 2s. This helium is known as inert gas configuration because this will not be able to fill anymore and it will not even react easily. This inert gas configuration is tried by the elements to be reached because it is the tendency of all these atoms to attain the inert gas configuration. That is why they react. Lithium, third electron, now comes in second energy level, and in that, in s orbital, energies of these orbitals s, p, d, f. F is of the highest energy, s is the lowest. So amongst s and p, s is the lowest. So the electron coming in lithium will go into s. In beryllium, there are 4 electrons. The 4th electron will automatically go to the available space in 2s orbital and be placed here. In boron, the 5th electron now cannot go here. It will go in any one of the 3. They are all equivalent. For simplicity, we write it in 2px. You can also write in 2py or 2pz. All are equivalent. 6th carbon atom and 6th atom electron in carbon now goes to another p. These two are singly filled. In nitrogen, 7th electron will again go in p, third p. Now you can ask, why does this electron not go here to make a pair? The reason is there is a Hund's rule which says that none of the equivalent energy orbitals can have more than one electron unless all those have attained one electron. So it is one here, second will go here, it will not pair. It will go in third. Now these 3 are occupied by 1 electron each. 8th electron of oxygen now will go into one of these. We put it here. In fluorine, another electron now, it goes here. In neon, so now all these are completely filled. And neon is an inert gas, and this is known as inert gas configuration. Electronic configuration of the elements may also be written as this: 1s2, 1s1 for hydrogen, 1s2 for helium. For lithium you can write 1s2, 2s1. For beryllium 1s2, 2s2. For boron 1s2, 2s2, 2px1. 1s2, 2s2, 2px1, 2py1. 1s2, 2s2, 2px1, 2py1, 2pz1 for nitrogen. 1s2, 2s2, 2px2, 2py1, 2pz1. 1s2, 2s2, 2px2, 2py2, 2pz1. And for neon 2py2, 2pz2. Now we will try to understand the shapes of these orbitals. S orbital is spherical in nature This is the nucleus, is spherical. 1s, 2s, 3s, all these are spherical. P orbitals are perpendicular to each other and can be represented by putting them on x, y and z axis. This was s orbital. This is shape of 2px or px anywhere, 3px is also the same. It is just like two balls put side by side on a table. This will represent the 2px orbital, and for simplicity it is written as this in our daily writing of the orbitals. 2 leaves. This will be the representation for our purpose. 2py, 2 balls, one above the other. This is dumbbell shape actually, and this can be represented like this. Two pz, this was x axis, this was y axis, x, y. Z axis comes perpendicular to these two, which cannot be written on the board. So, we draw a dotted line, that is one ball behind the other. And this can be represented like this. We come to the next concept, valence or valency. Valence is actually the number of atoms with which an atom can combine, or in other words, number of bonds an atom can form is known as valence. Hydrogen is univalent because it has only one electron in its outermost orbit. This is zero valent because it is paired. Lithium is again univalent. Similarly, fluorine is again univalent. Here it appears that beryllium with these paired electrons cannot form any bond, but in actual practice beryllium has two valencies. Compounds of the type BeCl2 are known. We will describe it in our next lecture, why it happens so. Boron appears to be univalent, but it actually is trivalent. BF3 is known. How this happens? Carbon appears to be bivalent, but it is actually tetravalent. CCl4. So, these have to be explained on the basis of hybridization, which we will see in the next lecture. Nitrogen is trivalent, oxygen is bivalent, 2 electrons, fluorine is monovalent. Neon cannot form bonds. Okay.